Alright, welcome back to Stu's Aircraft Factory. We're going to talk a little bit more about wiring and avionics in this one. The first electrical video that I put out talking about the master relay, the starter relay, the battery, shunts and all the big wires that have kind of the heart of the electrical system was quite well received, so I thought we'd do another video on the rest of the wiring that goes into this. It's a fairly basic system, like you've probably seen in the other videos. We have the GDU 460 screen, obviously with an AHRS. We have a backup, or actually a remote radio, remote transponder, carbon monoxide. Has ADS-B in and out. Has a GDL52R for XM weather and full engine monitoring. So it's a basic VFR system, but it's got all the Gucci stuff, and of course the autopilot is in there as well. So let's talk about the basic wiring and the switches and how I set mine up. Obviously yours is most likely going to be different, and most RVs have some obviously variation in the wiring that goes into it. So the first thing is the wiring that you see here with all the lacing on it is pre-purchased. So I had that made. It has the connectors, so that's going to take care of all the avionics talking to each other, as well as the engine monitoring system. It would be quite time-consuming and challenging to wire that yourself, because with the CAN bus system, you know, everything is talking to everything and has termination points as well, so it can be a little bit varsity to wire that yourself. The other advantage that you have of getting somebody to do it for you is, one, you got the support. Two, it's probably you're not going to have any issues. They're going to give you a fantastic wiring diagram here, which is actually quite complicated. So doing this yourself, even for this basic VFR system, is going to be quite challenging. The other thing that they're going to have in here is they're also going to tell you where the termination blocks go on the CAN bus system. I'll show you a picture of that. And the company that I use, Fast Stack Approach, they actually have some red writing in here of how to actually configure the GDU 460 to allow everything to talk to each other. So there's going to be configuration setups, setting baud rates, setting connectors, basically how to tell everything, you know, what else is it should be looking for, because there's tons of variations obviously in these setups. So that's one thing that, you know, hiring a company to do the wiring for you, it's not that expensive. It's going to be trouble-free. You're going to have fantastic support from any of the companies that I've dealt with, Steinair and Fast Stack Approach. And you're going to get this nice wiring diagram that's going to help you configure everything. So that's a huge advantage. So I recommend getting the avionics pre-wired. So after that, what's left for you to actually install for the wiring? Obviously all the antennas. So in this case here, we actually have two GPS antennas. We have an XM antenna, we have an ADS-B antenna and transponder antenna, and a radio antenna. So that's going to be up to you to run the cables for all the antennas. Obviously pitot-static AOA lines you're going to have to run yourself. And then on the panel, when we start talking about switches specifically, obviously you're going to wire that yourself. Obviously you can hire all that stuff out. You can buy a panel pre-wired and have everything done at several companies, but it's actually not quite that difficult to do. So I'll show you, you know, how maybe you can save some money, spend the money on the avionics wiring, and then do the rest yourself. That's the way I like to do it. Alright, so let's dive into it. I'll show you how I have mine configured. The first thing you're going to do, like I mentioned on the last video, is you're going to get yourself some wiring diagrams. So I get these from Aeroelectric Connection. I've modified them a little bit specifically for my airplane. There's no fancy program that goes into this. It's just a cut and paste of paint line drawing, Microsoft Paint, to lay out kind of where all the wires go and how they connect. Because DC wiring, although it's not that difficult, if you haven't done it before, it can be a little bit confusing the first time you dive into the electrical system on the aircraft. So having a diagram like this, you know, once you figure it out, you know, sitting at the desk with the references, with the manuals of the specific instruments, how everything gets connected, the P leads, the battery switch, the alternator, the voltage regulator, all that stuff, how it gets connected. Draw yourself out a diagram, do all that brain work sitting at the desk, and then when we get to the airplane, all we need to do is, how big is the wire, where does it start, where does it terminate, and then we worry about prettying it all up at the end. All right, so let's dive into it, starting with the master switch. Okay, so here we are in the cockpit. We'll start talking about the switches individually, show you how I wire them and what the basic concept is. So first of all, battery switch. You saw it on the previous video for the electrical diagram, and if we want to refer to it here, it's actually a 2-10 switch, so it has two positions. The middle position is the master, it essentially energizes the battery, and then all the way up would have the alternator after the engine is running. So if you look at our wire diagram, and like we explained on the previous video, the way that the battery is connected is through the master relay, and all we need to do is ground that pin on the side of the master relay. So one side of this switch will go to ground, and the other side of the switch will go to the pin on the master relay. When we do that, we hear the click, and that sound is the actual plunger, the magnetic plunger in the master relay energizing, and now we have power. Now, what do we want to power when we turn the master on? Do we want the transponder on? Do we want the radio on? Do we want the autopilot on? Do we want the magnometer, carbon monoxide? Do we want any of that stuff? For myself, the answer is no. All I want when I flip the master switch is to be able to start the airplane. So what do I need out of that? Well, obviously I need my screen. I need the GEA-24, which is the engine monitoring system. And obviously we're gonna have our ignitions powered as well. So that's really all we need. So if we look at the way that I did my diagram, and if we look at the fuse panel, when I go to battery switch, you know, besides nav lights and strobes and cockpit lights and all that stuff that's switchable, what is gonna turn on here? It's gonna be the screen, it's gonna be the GU24, which actually has 2 power leads. And I also power the GDL52R because that is what gives me XM weather, and it takes a few minutes to download. It takes about 5 minutes to download data the first time you do it. So when I push the airplane out of the hangar, turn the master switch on, I know that the XM weather is already starting to connect and starting to download. So by the time I have the engine started and I've done the run up and I've taken off, that I actually have some valid data on the screen. So that's all the avionics I power. I don't power anything else. You can see on the screen here, the radio is not powered. Now that one is a little bit debatable as well. There are some airports where you would talk on the radio before you started the engine, so you might want the comm to be powered. But for the comm, I've actually put that in the EFA switch down on the right-hand side here. So the AHRS is not powered, the carbon monoxide is not powered, transponder, comm, the autopilot is not powered. So you can see on the screen that initially, once we go battery, that we're going to have some red X's. So that's the master switch. Now, of course, we still have nav and strobe lights that we could turn on. We have cockpit lights that we could turn on. That's all going to go through the master, but it's all switchable inside the cockpit here, so it's not going to be on for the engine start and tax the battery. So that's the way I do it. As long as I have, you know, the engine data in front of me, and then I can get the aircraft started safely with all the parameters, and then I'll worry about turning on all the electronics after, once we have the alternator energized. All right, next switch all the way up would actually power the alternator. I don't do that until after the engine is started, so just to prevent any spikes. And then when you do that, obviously you'll see the voltage increase and you'll see the battery amps draw as it's charging the battery. So middle switch would be battery, all the way up would be alt. Now if we go back to our wiring diagram, what is that doing when we go up into alt? Remember, this is a 2-10 switch, so it actually has 6 prongs on the back. First time we go to battery, it's going to connect 2 of them. Second time we go to battery and alternator, it's going to connect the 4 bottom ones. And if we go to our wiring diagram, from our fuse block, we go to the alternator circuit breaker, which then goes to this switch, and then that goes to the pin, the bus pin on the voltage regulator, which is going to ignite or energize the alternator. So again, by having this diagram here, I mean, I can go into the installation manual for the voltage regulator and figure everything out, but if I have this diagram, I don't have to use any brain power at all to wire this up. The other thing I do on the wiring diagram here, I'll show you a close-up, is actually label all the wires. So inevitably someday we're going to be working on this panel, upgrading it, fixing something, who knows. So we want to label all of the wiring. And how do we label it? Well, label it any way you want such that it makes sense. But I actually put it on the wiring diagram. So if we look at the wiring here, you know, the wire that goes from the fuse block to the alternator field is called ALT2, AL2. And that will be labeled on both ends. So as I'm searching down there, if I find that wire that says AL2, I know exactly where it terminates. All right, and then AL2 again, going from that circuit breaker to the switch. And then from the switch, going to the B and C, I've called that one BAT 4-6. Just the way I like to use convention there is it's going from the pin 4 on the battery switch to pin 6 on the voltage regulator. So I just called it that to make sense. So all of this stuff here is actually labeled so that if you have a wiring issue, you can find it. Right, so that is the battery and the alternator. And like I said, I don't energize the alternator until after the engine is running. All right, well, let's talk about the PMAGs. So I have two switches, one for left PMAG, one for right PMAG. But for PMAGs, you also have a circuit breaker. So there's only 3 circuit breakers in this plane. One for alternator field, like we've shown you in the diagram here. And just in case that trips during flight, you want to be able to reset it. And then you're going to have an individual circuit breaker for PMAG. Now there's different ways to wire the PMAG. But essentially what you need to do is this. The switch is the same as a normal magneto, right? When I turn it off, it's going to ground the pin on the mag and kill it, right? So it's actually wired backwards from most switches, like for the fuel pump, for example. If I turn that on, it's going to energize the 2 bottom pins, which is going to give power to the boost pump. For the PMAGs, and I'll show you the back of these just so it's clear, when it's off, I'm connecting the 2 top pins, which is then going to ground out the PMAG. So in fact, when it's up, the 2 pins on the bottom of the switch that are connected, there's no wires going to those. So by going up, you're kind of removing the kill switch, if that makes more sense to you. So it's wired the same as a magneto. In fact, when you go down, you're actually connecting 2 wires together to make sure that the PMAG is grounded and that it goes off. But why do we have circuit breakers? It's because the PMAGs are self-power generating. So during our run-up on the ground, we want to make sure that it's actually generating its own power. So there's different ways to do this. You can combine switches. You can have a momentary up switch that will remove power. But I've just elected to put 2 circuit breakers in here. So during my run-up, I'm going to be 1800 RPM. I'm going to do the same as a PMAG test. I'm going to shut one ignition off at a time, make sure that they both work, make sure I don't get a rapid drop in EGTs, and everything is firing, all the spark plugs are working. Now I'm going to go down to the circuit breaker and I'm actually going to pull the circuit breaker power to one of the mags. Now nothing should happen. The PMAG is already running. The beautiful thing of the PMAG is it generates its own power. So here we're just making sure that in fact it is generating its own power. So we remove the aircraft power from the PMAG and it should keep running. So in fact the generator is working. So we'll do that to both and we'll pull the other circuit breaker to the other PMAG and then make sure that that is generating its own power as well. So PMAGs are not complicated, they're very simple. My recommended ignition system for the engine, wired the same way for the on-off switches as a normal mag would be. And then they're going to add some way to kill power to it to just make sure that the generator is working. So that's the ignition switch. And then on the right side we have the boost pump, and very simple wiring for that comes from the main bus. So power from the main bus, from the fuse, will come to the bottom switch, and then the middle pin will go to the boost pump power, and then at the boost pump we'll obviously have a ground wire. So there's two wires going to this, one power from the fuse block and the other power wire from the actual boost pump, so that when we turn it on, we actually hear the boost pump ignite. So that's the switches on the right. Then for the USB here, this is a simple wiring as well, just basically it's power and ground to the back. So there's two pins on the back. One will go to the fuse panel, which has a fuse obviously to protect the wiring, and then the other side will go directly to the ground. So that's simple for that. There is no switch obviously, just obviously plug into it. At the top here, we have our lights. So we have a start enable light, and again, wiring this one can kind of keep it easy as well. So because I have the start switch on the stick, I don't want that to be live. So if I accidentally hit it during flight, I don't want the starter to actually energize. So I have a kill switch on the right hand side here. So this is a start enable. So if we look at our wire diagram from our main bus, we have a start fuse, and then we go to our start enable switch. So if I flip that on, I'm then going to get the green light saying this switch is now hot. So that goes from one pin of the switch to the positive side of the light, and then the negative side of the light will go to ground. So that's going to energize our light. And then also from the back of this switch, once we go up and it energizes the light, it's also going to energize the circuit that goes to the start switch, which is a momentary button. And then the other side of that start switch, according to our diagram, then goes to the terminal point on the starter relay. So remember, we ignite the starter relay through power, and we energize the master relay using ground. So if I push that switch right now, it's going to energize the starter. Obviously, I'm not going to do it in the hangar. That's how that start enable light works, and that's how that start enable switch works on the right hand side here. And then there's a starter engage light. If for some reason the starter didn't disengage when you let go of the switch, then this light would stay on, saying that the starter is still energizing, which would be bad. And at that point, you'd have to shut down and figure out why that happened. So that's an easy enough. There's another little pin on the starter contractor labeled I believe for indicator. That goes to one side of this light, and then the other side of that light will go to ground. Now we have a bat fault light here as well. So because we have an EarthX battery, there is a wire coming from the battery to show if we have any faults. And if you look up the EarthX instruction manual, say if it blinks every so seconds, this is what it indicates. Essentially, it's just telling you that potentially there's some bays that are low voltage. And I've actually had it go off when I'm testing everything in the hangar, and I had the master on for a long time, just basically telling me that it's getting a low voltage. And how that's wired is from the EarthX battery, it's going to send out a ground signal. So this one is a little bit different than the two other lights in that when there is an actual battery fault, the EarthX is going to send out a ground signal. So that's going to go to the ground side of this, and then you're going to wire the other side of this battery fault light to actual power, so battery fault. So if you look at the fuse panel, we actually have a fuse that's called bat light power. So that's how those lights are going to work on the top there. All right, on the right side, the ELT, that's pretty straightforward. It doesn't really get wired into the other system except for GPS. Flaps is a neat one. This is just a generic, kind of up-down system. You have to hold it to get the flaps to travel. There are systems where, if you click it down, it'll go 10. You click it again, it'll go 20. You click it a third time, it'll go 40. This one's just basically up-down. It's very simple to wire it. If you look at the switch, it has 6 terminals on the back. In the middle 2 terminals, we'll run power to one side and ground to the other. And then we'll actually tie together the top left and the bottom right pins just with a wire, and we'll tie together the bottom left and the top right pins. And then in the top, we'll run one wire to our flap motor and the other wire to the second wire on the flap motor. Now this is kind of neat in that when we go up, it's going to send power to one side of the flap motor and ground to the other, but when we go down, it's going to reverse the polarity. So that's all we need to do for the flap system. It's actually quite simple, and a neat little trick of running wires kind of in an X pattern to connect those terminals together. So hopefully that makes sense. Very simple wiring. And the first time you do it, if it goes backwards, then you're just going to flip the power and the ground terminals, and you're good to go. Elevator trim, quite similar. It's going to have a power wire and a ground wire, and then 2 wires going back to the elevator trim itself. There is other sensor wires that you can put in there and know where the trim is, but I personally just look at it on takeoff, set it to neutral, and adjust it in the air. So I don't have any trim indication in the cockpit, but you can wire it to the G3X if you want. And again, that's quite similar. It's got nose down and nose up. And if it runs backwards when you first install it, you're just going to take the 2 wires from the trim motor, and you're going to flip them side to side, and then it'll run the proper way. So I think that's everything on the dash that we've talked about. Let's go back to the GDU. So a couple switches on the side here. So I have an EFIS switch and an Avionics switch. The EFIS switch is going to turn on my AHARS. So the AHARS is going to energize, the GPS is going to energize, the magnometer, and actually the radio. So if I flip the EFIS system up, you'll see that the AHARS starts to align, the comm radio comes in, and we get rid of the X's on the airspeed and the altimeter. And of course, it takes a little bit of time for the AHARS to align itself, a few seconds, but you see we still have the X for the transponder because that's going to be energized by the Avionics master. And essentially what the Avionics master is going to do is has both of the roll servos as well as the carbon monoxide and the GT35, so the transponder as well. So here's the AHARS aligning. I'll show you a nice close-up of this. All right, so the AHARS is aligned, but again, we still have red X's on the transponder and on the autopilot. So if we turn on the actual Avionics master, now the carbon monoxide comes on, our transponder comes on, and our autopilot is also powered now. So that's everything that we don't really need, obviously, for the start. Like I said, the comm is somewhat debatable. Some people like having the comm radio just in case they need to talk to ground before the engine starts. So the rest of the switches on the side, we have landing lights and taxi lights. The middle one will go to 1 taxi light. The top will be the taxi light and the landing light. So there's actually 2 lights. And it's a 2-10 switch as well, similar to the battery switch, where the center position energizes 1 circuit, which is the taxi light, and then the top energizes the taxi light and the landing light. Next to that, we have Nav Lights and Strobes, and again, that's another 2-10 switch. So if we go to the middle one, it's going to give us Nav Lights, and if we go to the top one, it's going to give Nav Lights and Strobe Lights energized on the side. 3 circuit breakers like we talked about, carbon monoxide light here, and then we've got a test button for that as well. And then the last switch that we have here is Cockpit Lighting, which is a rotary on and off switch, which gives us lights under the dash. We do have a heat control as well, which is going to open the heat muff on the firewall to allow hot air to come off the exhaust and into the cockpit. I typically do it with a cable, but it's really tight in the RV4, so I've elected to use a little linear actuator, and I just basically turn the heat on and it opens up the heat. And then I can adjust the actual amount of heat through the eyeball vent here. Okay, so that takes us through the dash and looking at the back of the switches at the same time, so it makes sense. Hopefully that helps you on your build. DC wiring is not hard. It's just, if you've never done it, it can be a little bit of a mystery when you first start. But think of electrons as like a river flowing. So the electrons have to go from the battery to the fuse panel, from the fuse panel to the switch, from the switch to whatever it's operating, and then a ground wire besides that. All right, if you have any questions, let me know. Build yourself something, take it for a rip, and I'll see you guys in the next video. Cheers.